Ever cast your reflection and think, why do we even age?
It's one of those big questions, isn't it?
Feels like it, yeah.
Yeah.
And the answer, well, might be even bigger than we are. Literally.
I like where this is going.
Looks like you've been on a similar wavelength articles, research, even a whole ChatGPT deep dive on aging. So buckle up, because today we're not just tackling why our bodies get older, but how it links to the entire universe's fate.
Sounds like a plan.
And it all begins with this thing called entropy. Don't worry, it's not as complicated as it sounds. Imagine cleaning your room. Everything's perfect, right where it should be.
I wish.
Right. But then life, it's busy, and suddenly, bam, chaos reigns again.
It's the story of my life, and the universe's too. Always leans toward more disorder over time. That's entropy, simple as that.
So even our amazing bodies can't escape it forever.
Even us. Think of your cells like tiny machines working tirelessly, repairs, maintenance, keeping you.
Keeping the lights on.
Exactly. But over time, those repair systems, they get a bit slower.
Like an old car needing constant tune-ups.
Spot on. Eventually, those tune-ups just aren't enough. Now, biologically speaking, there's a reason for this decline. Ever heard of telomeres? They're like those protective caps on our DNA.
I've come across it. Yeah, they get shorter or something.
Every time a cell divides, those telomeres, they shrink a little.
Our biological clock ticking away.
You got it. And there's a limit to how many times cells can divide before those telomeres are, well, gone. That's the Hayflick limit. Basically, our cells have a built-in expiration date.
An expiration date. Makes you think, huh?
It does. But that limit's essential. It prevents uncontrolled growth, which, is cancer. Trade-off for you.
So it's a balance between living longer and, well, something much worse.
You got it. But it's not just about those shrinking telomeres. Our cells constantly face damage. Oxidative stress, for one.
Oxidative stress. All right, you lost me. That sounds like a superhero problem.
Trust me, it's very real. Our cells use oxygen, good for us, right? But it creates these byproducts, free radicals, like tiny troublemakers messing with our DNA and whatnot.
So our cells are constantly fighting these little villains.
That's one way to put it. And as we age, our defenses, let's just say they get tired. Damage piles up.
So between these free radicals, the Hayflick limit, our poor cells are fighting a losing battle.
They are amazing though, right? But here's where it gets even wilder. This is all connected to something much, much bigger, the universe itself.
Okay, now you got to break that down for me. Okay, so our bodies are like these incredible machines constantly fighting against damage and decay. But you're telling me this is all connected to something even bigger, to the universe itself. That's where I need you to break it down for me.
Absolutely. It's like this. Imagine a drop of ink spreading out in a glass of water. It naturally wants to move from order, all concentrated, to disorder, all spread out. That's entropy at work. Always pushing towards that even spread.
Okay, I see, I think. So our bodies are trying to keep it together, stay organized, but the universe wants everything messier.
Exactly. And that brings us to the expanding universe. As the universe expands, it cools down. Energy spreads out more evenly, which means more disorder, more entropy.
So more space equals more room for, well, mess. It's like the universe is a room that just keeps getting bigger, harder to tidy up.
Love that analogy. And there's a theoretical end to all this, sometimes called the heat death of the universe. Don't worry, we're talking way far off in the future.
Heat death does sound kind of ominous. What does that even mean? Like an explosion or something?
Not quite. More of a slow fade out. Stars burn out, no new ones form, and the universe is this cold, dark, spread out place.
Bleak. So our own aging and eventually, well, dying. It's like a tiny version of this whole universe process.
In a way, yeah. We're all part of this cosmic entropy dance, from our cells to, well, everything out there. But there's a flip side.
Okay, now you really have my attention. What's the flip side?
Think about it. No entropy, no tendency towards disorder means no change. No time, even as we know it. The universe would be frozen.
So entropy is what makes time move forward. Mind blown.
It's a trip, right? Makes you think about aging and death differently. Not just endings, but part of this massive change fest since, well, the Big Bang.
Give me a sec to process this. It's incredible how our lives, how we experience time, it's all tied to the fate of the universe.
It's remarkable, and it makes you wonder, What happens to all that matter, all that energy as the universe keeps going?
All right, I think I'm starting to grasp this whole entropy thing. It's like this constant force pushing change in the universe, even if we experience it as our bodies, slowly breaking down.
A very astute observation, and it raises a fascinating question. What does happen to all that matter, that energy, when we die? Does entropy just stop?
That's a good question. Haven't thought about it like that before.
Well, the short answer is no. Entropy keeps going, just like with everything else in the universe. Remember our sandcastle analogy?
Oh, yeah. Beautiful, but kind of sad.
Exactly. When we die, our bodies, those intricate structures, they break down. It's natural decomposition. But that matter, it doesn't just vanish.
So we kind of become part of the universe again.
Exactly. Those atoms that make us, the carbon, hydrogen, oxygen, they're recycled back into the environment, maybe part of the soil, a plant, even another living thing someday. This constant cycle of change driven by the arrow of time, which, as we've learned, is totally tied to entropy.
Wow. So even in death, there's this continuation, not an end, but like changing into something else.
That's a very poetic way to put it, and not entirely off the mark. Scientifically, death is those biological processes stopping, but on this bigger scale, it's just another step in the universe's dance of energy and matter.
This whole deep dive has been amazing. We've gone from tiny cells to like the entire universe's fate, and it's all connected by entropy. A lot to take in.
It certainly is, but that's the beauty of science, isn't it? Asking big questions, figuring out where we fit in.
Absolutely. Who knows what other mysteries are out there waiting for us to discover. To our listeners, thanks for joining us on this deep dive. We hope it sparked your curiosity about the universe and our place in it. Remember, even though entropy might seem a bit daunting, it's also what makes life, time, change, everything possible. So keep those big questions coming and never stop exploring.